Please go ahead and take over. But I wanna start by asking, were people at Novartis upset that Pfizer found the vaccine first? So that's my biggest question. So, but after that, you can start. Please go ahead.
Sure. Probably there were people who were upset because of the huge potential and the huge money-making machine that this would be. But I think in the end they decided to cooperate. I mean, this is the oldest problem in game theory. They decided to cooperate and they decided to help. I think they are helping Pfizer produce it and manufacture it in our company. But yeah, we don't have Novartis doesn't have a vaccine developed itself. So okay, let me start by sharing. Okay. Perfect. Let me know if you can see my screen. Okay, can everyone see my screen? Perfect. So this will be a short introduction to AI and NLP and the application that it has in various in the industry and also for research. So I'm not sure how to take this away. You're not seeing, like I see the Zoom on the side, like you don't see that, right? You just see the pure presentation.
No, we just see your screen.
Okay, wonderful. And I'm not sure how I minimize this. Okay, I minimized it. Perfect. So okay, so I will give a very high level introduction. So obviously NLP is a very broad field, and there are many applications, and there are many things going on. So right now, I would say some of the brightest and smartest people in the world were hired to do research in this field. Obviously, I'm not one of them, but Google and Facebook, which are at the forefront of research and advancement in NLP, they are investing millions and billions of dollars just because of the potential of getting information from text. So and as I think as a consequence of that, there is the research is advancing very fast. And when I say very fast, compared to other fields, it's not even comparable. Like here, if you don't keep up with the literature for like 3 or 6 months, then you're completely outdated. Like it's going to be very difficult to catch up with new things. So you kind of have to relearn most of the things that every, I'd say, 2 or 3 years. And when I give a short history of NLP, you'll see what I mean by that. So okay, this is an outline. So I'll begin with some history, and then I'll talk about what I call the NLP Revolution, which happened in 2017, and then I'll give a few examples of usages of NLP in business and also in research. So since my background is in economics and finance, I will give the examples from there. But I think it's pretty straightforward to interpolate these applications in different fields, especially in the social sciences, where text can be important to answer different research questions. So this is a short history of what happened in NLP in the last century, I would say. So in the 1940s, 1950s, the two, I'd say, parent fields of NLP, which are computational linguistics and probability and statistics, the theories there were kind of developed. You have Chomsky and these other guys in computation in linguistics, and also Shannon. So people from engineering background will know him very well. So, and then from the 50s to the 1990s, there were advancements, but they were, I would say, pretty slow, and not much happened. Then after the 1990s, there were some, it was a little bit faster, but still there was no like explosion, right? You couldn't see that fast advancement yet. After 2015, people started using probabilistic models to model text, and that's where I would say things started to change. So recurrent neural networks and LSTMs, bio-LSTMs are part of them, were developed, and then convolutional neural networks were used to model language. They were good. They were giving good performance. So when you think in terms of classification, like they were somewhere at 60-70% of recall, which means that out of, I mean, if you're kind of let me give an example of classifying your email, right? You want to classify if an email is a spam or not, so that you can throw it to the spam folder. If you say that spam is a 1 and everything else is a 0, like regular emails, I want to get them. I want to filter out all of the spams. Then a 60-70% recall means that it's going to filter out 60%, 60-70% of the spam, and you'll see the rest basically. So you're going to see like 30-40% of them in your inbox. And then after 2018, the revolution came, and the attention-based models such as BERT, which is the workhorse of NLP, currently was introduced. And then there other versions of BERT, such as Albert or Roberta, were introduced. And I'll explain what they are, but for now, let's just the name is cool, and actually my dad's name is Albert, so that's it. I was kind of amazed when I first learned about this model. So what's going on in NLP, and why is it so hard, and why are so many people or so many companies very much interested in NLP? First is that NLP is hard, and there is a lot of ambiguity in the language. So depending on who is saying something, depending on the context, and depending on who he or she is talking to, all of the meaning of the sentence is going to change, right? And I missed being a millennial by a few years, like maybe by 10 years or so, but I like memes. So you have this lady here who is a housewife, and she's complaining, right? So she's using some sarcasm there. Like when we read it, we're human, we understand what's going on, right? So she says, he asked why the house is clean since I'm home all day. I asked, why aren't we rich since he works all day? So like this is sort of funny to us, like we understand it, and it's funny, it's interesting, but the machine will probably assume that these are two different statements, and most probably it won't even get that this is funny, or it won't understand the context and what she really means by this, right? It will just get whatever there is in the words, but there is so much going on, right? So another reason why NLP is difficult is because there are multiple words that can be used for the same concept, right? And the meaning of the sentence is going to be slightly different with each of these different words. So this is a very brief, and I will not go into like mathematical details, but this is a brief introduction of LSTMs. LSTM stands for long short-term memory. So the challenge with modeling sequential data, and people who have worked on time series will it will be very easy for them to understand what I mean by this, is that things that happened in the past are going to have some effect on the current state of whatever process you're looking at. So when these are words, something that you said a few sentences before might affect or might be relevant to what you're saying right now in the current word, right? So there's a sort of a flow, and what they did is they used this LSTM cell, which is this one here, which creates this context. You can think of this as a vector, okay? And this vector has information about what was going on the like from the beginning of the paragraph or of the speech until at the current word, right? And there is a gate. So this gate is going to decide how much information from this context is going to go to the next word. And there is also information added from the current word, right? So this is basically the working principle of LSTM. And all of these axes, x0, x1, x2, x3, these are words, right? And the information that flows from the first one to the second one to the third one, this is the context, right? And also there are these hidden representations here. So this is basically the encoded version of the axis. So long story short, this is a way to get some memory and for the model to remember what was there a few words before, right? So this is good, and this was giving, as I said, like 60–70% performance. One challenge with LSTMs is that you really need to train, you really need a huge amount of data to train them, and they are very slow, and you need to, you know, like they are very slow and they need a huge amount of data, so it's not really feasible to retrain them frequently. And you know, this and also the performance is quite low. They were used for some time. One other disadvantage, and sorry for forgetting that, but one other disadvantage is that you're only looking at the information flow from the left to the right, which means that when you're trying to predict the next word, you only know the words that were there before that one, right? But you don't know what's going to be there next, and this gives only half of the context. So when people read a paragraph, you are going to look at the whole at all of the words, right? You don't cover everything on the right hand side and just read whatever was there until the current word that you're looking at. So that's I'd say one of the disadvantages of LSTMs. So then the revolution came, and there is another meme here. Sorry, maybe I'm being too much of a millennia here. But so in the beginning of NLP, they were modeling, they were constructing language models by looking at the frequency of the words, right? And this guy says that you cannot just understand the text by looking at the word frequencies. I mean, that simply doesn't make much sense. So what happened in the NLP revolution? Attention was.
Can I interrupt? Sorry.
Sure.
Can you, so the example that you gave about the email was very helpful. Can you, when you're talking about, can you mention some applications? So is this just for Google search or like email, when we write our email? If you can mention some applications, that would, for me, it might be helpful to.
So I will get to applications later, but so the idea is that you want to model the language, right? And how you do that in LSTMs is you try to predict the next word using the previous few words. For example, when I say hi, I am from New York, right? What I do is I start with hi and I try to predict the next word, right? And then I include the next word, not the one that I predicted, but the actual one, and then I use the first two words to predict the third one. And looking at the difference between what I predicted and what the actual one was, I create a loss function. And this is what I actually minimize in the end. So this is sort of, you know, when you do OLS, you're minimizing the function, right? If you're doing regression, that's a mean squared error. Right. So this is similar to that one. And you're training this model to understand, basically to understand the language. This is the kind of the ultimate goal. And you can use that model that you train there for different tasks. You can use it for classification, because once it learns how to understand the language, it can do like different things. This is sort of similar to learning a foreign language, right? So in the beginning you learn the language, and then you can use it for different tasks. Like you can write a an essay, or you can write a song or things like that. You can think in that sense. So basically, in the beginning, you learn the language, you learn how to understand the language, like the patterns.
It's also hard to understand the sarcasm when you are learning a new language too. So that
exactly.
that is also similar. Interesting. Yeah.
Yep. So if there's any other question, I can take them. If not, I can continue.
Well, I have been asking questions through chat to you, but
I'm sorry, I'm not looking.
No, that's fine.
Chat.
You can take a look at it, or if it's related, you can answer it right now or along the way.
Okay, let me look at the first one. Left to right design is great for many languages. For a language that it's written and read from left to right, how does LSTM work? When in that case, you just train LSTM from left to right. You can do that. Like,
you mean like right to left, or it kind of changes?
You can change it. Like, there is something called by LSTM, and that was the next step after LSTM. So basically, you have information flowing from the left to the right, and also have information flowing from the right to the left, and you train both of these models simultaneously.
Okay. And the second one is the Microsoft Word. When people are typing something on smartphones, and it kind of corrects or kind of guesses, predicts the next word. Is it the same thing?
I think most probably a few years back it was LSTM, but not anymore. So now most of them are using BERT or some version of BERT. Like most probably Microsoft Word has some small tiny version of BERT that it's using, because you need to fit it in the memory of the cell phone or things like that. Those are the challenges there. But a few years back, LSTM was the state-of-the-art model, and most of the NLP applications were done using LSTM until 2018 at least. But then after 2018, this revolution happened, and attention was introduced, and right now, like, almost nobody's using LSTMs anymore. So okay, let me minimize this. So attention was introduced. What attention does basically is, instead of just looking at information from the left only, or from the right only, it looks at sort of correlation, or I would say association of words with each other. Like, it creates this attention mechanism where each word is attended to each of the other words in the paragraph or in the text that you're feeding into the model. So you have this like one-to-one corresponding relation between each of the words with each other, right? And this is the really cool thing, because you're getting context of the surrounding words, and that's really important for the model to understand what's going on. Instead of just knowing whatever happened so far, you get a high-level view of what is there in the whole paragraph. So Bert and Roberta and Albert were introduced later on. So just to give a context of how large these models are, BERT large, which is BERT has a few versions, and what is different is the number of layers that they have. But the largest one has 340 million parameters. So when you estimate an OLS with, let's say, 10 variables, you're estimating how many? 11 parameters, right? And you can kind of compare that to BERT. So one of the I would say the challenges for some startups with these models is computational power. Even though, like, right now, Amazon and Google web services or cloud services, they are making it possible for most companies to use these models. This model typically don't fit in a laptop. You need some cloud service to be able to use them. So this is what BERT does, and this is built on the transformer architecture. So you have a few layers of transformers on top of each other, and transform itself is built on the attention mechanism. So without wanting to go into much details, what's going on is that this BERT here, and by the way, BERT is the name of a character in kids movies. and they like using this
Sesame
name.
Street? Is that the one? Sesame Street?
I think so. And there's another guy, Elmo, I believe, and for some reason they like using these these interesting names. So basically, what's going on is that you're training the model on as many data as you can find, right? So typically they train it on Wikipedia data, and they get data from like text data from books and newspapers and websites, like whatever you can think of that has text in it, and they train this model. So what is trained there is these layers in yellow here, and then after the model has sort of learned the patterns in the language, it knows how to understand the language. However, it doesn't really know how to do different tasks, right? For example, you want to classify sentiments. Does this, you have like, let's say, comments, and you want to classify if they're positive sentiment or negative sentiment, right? So even though the language, the model knows how to, or has learned how to understand the language, it doesn't know how to classify things into like good sentiment or bad sentiment. So that's what it does in a fine-tuning step. So you can, like, what we call the first one is pre-training. So that's where the BERT model is created, and then you fine-tune it on specific tasks. For example, here to detect spam versus non-spam. So this achieved really state-of-the-art results, like with language. As you know, I mentioned in the beginning, it's really challenging because you have ambiguity, and depending on who says it and the context, the meaning is going to change. It's not the same with images. So people who come from computer vision, they're kind of used to getting performance in the 99 point something% recall, or for example, when you classify images like cat or dog or car or house or things like that, these models perform pretty well, because like if it's a house, it's a house, right? I mean, that's pretty straightforward. Even though the performance is not 100%, it's very close to that. But when it comes to language, the performance is typically much lower. So 90% was previously unseen in NLP, and this is why I call this revolution. So basically, the performance jumped suddenly by 20-25% compared to LSTMs. So this all happens because of transfer learning. So transfer learning is training a model on something. So it was pre-trained on Wikipedia data, right? And other huge amounts of data that are available out there. And you take that model, which was trained somewhere else, and you kind of fine-tune it to do a task that it was not trained to do, right, originally. So this is what is called transfer learning. So you train something to do a specific task, and then you apply it to a different task, and it works pretty well, actually. So these are now going to applications of NLP. The first obvious one is machine translation, like Google Translate, or other translation engines that you probably have heard of, or information retrieval, right? So another interesting application of NLP is when you have these massive amounts of data that you want to maybe summarize, or you want to get some information from there, right? Like you wonder something that is there in the text, but you don't want to go over all of it, and you can use NLP to kind of find that information for you. Or you have this information in ask different questions regarding topics or ideas that are there in the text, or you want to summarize it, right? You have these like long reports, and you don't want to go over all of it. Like think about CEOs, their time is very valuable and precious, and they don't want to spend all their time like reading endless reports. So this is quite useful for them. So how are businesses using NLP? Well, obviously, before you had these manual annotators, right? So if you had, let's say, you own a business, right? and you have these reviews that come to you via different vendors, like it can be Facebook or Twitter, like people write reviews, or Google reviews, and you want to, maybe in real time, you want to track how your business is doing, right? How good or how bad the reviews are. So what you had to do, in the old gold times, you had to hire these crowds of people, and I put this picture here. You need to hire an army of people to do that. Like, think of Facebook, or think of these large companies that have like huge amounts of data. If you want to do it manually, then you need to hire those people who are going to sit down, right? 0 or 1, good or bad. Or you can do it multiple categories. And use it to substitute this army of people. And now, instead of having to pay them millions of dollars a year, you just need to pay a few $100,000 to the machine learning engineer, or to the data scientist, and they can build a product that is going to do that for you. Now, this is not there yet to replace humans 100%. Still, you need humans in the loop, just to make sure that the model the model's performance is not deteriorating. Like, typically 20% of the data is still manually annotated, just to make sure that the model is performing as it should. But the cost has been reduced by a lot, like up to 50, 60, 70% of the cost that it used to be. Search algorithms, such as Google search, you write something there, and it gives you the sort of recommendations or it gives you the search results. Or recommendation algorithms, right? You open Netflix, for example, and based on your previous searches, or based on the movies that you have watched, is going to give you a recommendation for other movies. Or your Facebook feed, that's another example of recommendation algorithms. Machine translation, such as Google Translate, or classification or event detection. For example, what is interesting for pharmaceutical companies is detecting adverse events. Like, you get a drug, and you have an issue afterwards that needs to be reported. Or chatbots, like even USCIS, or other government agencies, even they are using AI to communicate with customers and to answer their questions before they transfer it to a human, and the human helps them. So, or you can, it's also used, I think I already mentioned it, to extract and process clinical data in pharmaceutical companies. And also I think hospitals also are interested in NLP, and they are using it. So I want to give some examples of NLP applications in research. Sure.
Is that video recommendation, like Netflix or YouTube, is the same logic as the language processing? Even though it's not a language, is it? No, right? That's not words.
I think they get the transcripts of the movies, but there, in addition to NLP, I think they use other individual information that they have, like if you know what somebody likes, and if you know who are his or her friends, and what their friends watch or what they like, then you can kind of build that cluster or network of interests, and you can use that information from there. Another one is this, like movies is also data. Like you can translate that into just like you do with words. You can create vectors from that data, and you can use that data instead of like you can do similar things that you do with language. You can do it with speech or even with movies. So NLP, this is a summary published in 2020, which gives a pretty good idea of how NLP is used for research and finance. So just to give an overview, these are the typical questions that it helps answer. So when you want to do financial predictions, right? For example, you want to predict the stock market, or you want to predict the foreign exchange, like the exchange rates. You can get data from maybe Twitter or stock tweets or things like that are going to give you an idea of the sentiments in the market for a certain stock, right? And you can use that sentiment to predict the stock price or the stock price movements. It can be used in banking to detect money laundering, or for risk management, or for customer relationship management, or in corporate finance to analyze reports, or fraud detection or things like that. So the methods that you use in all of these are only a few. You can do clustering. For example, you have different texts, and you want to kind of group them together according to some similarity measure, right? You can cluster them together, and then you can after building those clusters, you can maybe study like who is there, and why they are similar and what's going on, and you can sort of use that information in other analysis. Or you can do sentiment analysis, like is it a good sentiment or a bad sentiment, or you can do like classification. So this approach here is kind of the natural language-based finance forecasting. So in finance, we're typically interested in doing forecasting things like such as the stock price or the exchange rates. And you can do that by using NLP. So in NLP, you can use topic. Topic is basically clustering similar documents or paragraphs together. You can use information from dialogues, or what else do we have here? Semantics, which is also important, or media, like typically newspaper headlines or newspaper articles are used to get sentiment, and using that sentiment, you can do different things. So what you can do with the sentiment is, and this is a paper from Rob Engel from NYU and a few other researchers. So what they did is they looked at climate change, and they have this hypothesis that investors or fund managers, they hedge against climate change news. So whenever you have a lot of media coverage for climate change, they're going to adjust their portfolios accordingly. And so basically what they did is they took these climate change reports from the government somewhere, and they took all of the newspaper articles, and then they found some sort of similarity between those two huge texts, and then they used that similarity, like they did it, I think, monthly, and then they used that to build the portfolios. And then they found that actually this is happening. So investors are hedging against climate change news. And this other paper, the one on the left, is a work from the Federal Reserve, where they are using news sentiment to predict macro variables such as GDP or other. I don't think they did for inflation, but they typically do this for GDP, or to basically measure the state of the economy. So what's the typical workflow of an NLP project? First, you have to define what you want to do, right? And then make sure that NLP can help you with that. So NLP is very strong right now, and there are a lot of developments, but it's still in an early stage, and it cannot do everything for you. It has some limitations. And then you need to identify or create, and the second one is what actually happens most of the time. You don't have a fine-tuning data. So basically you need, based on the question that you have, you need to define how you're going to do the annotation. Right? For example, if you are trying to detect some event that is happening in some text data, you will need to create the annotated data accordingly. And not most of the time you don't have that annotated data from somewhere else. You need to create it yourself. So and I put this quote here, and this is mine. If you can explain it to your friend, you both can annotate some data. So if you can if you can create like simple rules, for example, if there is a mention of this, then this is this event. If not, then it's some other event. Using those simple rules, you should annotate the data and use that annotated data to fine tune the model, and that model is going to perform pretty well. So typically it's above 85, or BERT typically gives you a performance which is close to 90% we call. And then you need to assess the model performance in the downstream task. And maybe you need to track this with new data that are coming. And to do that, again, you'll need to do some data annotation, like sample some percentage of the data that you're receiving. Like, if you're using this in production, you need to make sure that the performance of the model is not deteriorating, which happens many times. And then you can use these models to process amounts of data, and this is really powerful. So you can train a model with as few as a few thousand data points, and you can use that to process millions or even like billions of documents for you. So this concludes my presentation. I want to do a very short demo, and just to to give an idea of how simple it is to use this. Like there is a startup based out of from Brooklyn, New York, called Hugging Face, and their kind of goal is to democratize NLP and make it accessible for everyone who wants to use it. And I can actually go there and show their website and what you can do from there. Before that, is there a question?
There's one person raising his hand.
Oh, okay. So maybe I can ask my question again.
Sure.
So that we'll go from there. So my question was the typical workflow that you explained in your last slide, I guess, for NLP applications. And I was asking, like, that workflow might be for a specific domains, for example, like finance or business applications. But do you think is that specific to those domains, or it can be generalized to other domains as well?
So at least with my experience, it can be generalized. And if you're able to, as Einstein said, right, if you can explain something to your grandmother, then you have understood it. If you can explain something to your friend, you can actually explain it to the model, and the model will be able to use that information, because so basically there's a way our mind is working, and that's what these models are trying to replicate. So when you do that annotation, and you can think of you read employer evaluations or employee evaluations, and you want to rank them, right? Like you want to give a score from 0 to 10, let's say. How can you do that? So you annotate them, a few of them, and there's something that you're thinking of when you do that. Like, for example, like if the employer says this, then this is 0, and if this isn't mentioned, then this is 1, and so on and so forth. And implicitly, the model is going to learn all of these patterns from the data that you feed in, because you're feeding in the text and the corresponding score from 0 to 10. And the model is going to learn about these patterns, and it's going to use that knowledge to annotate new data.
Sure. So my follow-up question to that, so in most of the, some of the domains, specifically domains with, that might have some serious implications in individual lives or society or communities in general. So it can be healthcare domain more specifically, or it can be some other security or safety domains, for example, right? Sure. So maybe in finance domain as well, because it may impact actually people's financial situations. That might also have implications to their mental health care and so on, right? So our observations were actually, so annotation is even though it can be seen like as a trivial step in like data science or AI kind of applications or NLP applications, but it's a very critical stage actually, because it's going to set the precedence, or it's going to set the ground truth actually for your model. I mean, regardless of the sophistication of your model or your algorithm, if your data set is not actually appropriate to use, or it's not is not actually a good quality data set, then no matter how good your algorithm or how good your model is, it's not going to work, and it's not going to provide good quality outcomes, right? And in our like very recent work, for example, it was not in finance domain. It was actually in some online extremism domain, for example. We used like Twitter dataset, and it was the dataset verified by Twitter. So it was like annotated by Twitter, and they suspended the account because they were actually trying to radicalize people in general, and more specifically, they were actually trying to radicalize people for Islamist extremism. However, we found actually misclassed or mislabeled users that were labeled as extremists. They were actually not extremists in the first place. And that was like verified, quote unquote, verified. So, and it was like 10% of the ground truth data was actually mislabeled. And when you take this data set and train your model over this data set, then it's going to mislead you as a data scientist because you are going to rely on the outcome of that model, right? And it may actually have a lot of implication. And when you think about, like, when you deploy this model in your pipeline overall, like business pipeline, that is going to be used like by maybe thousands of people or millions of people, then it's going to mislead, or it's going to have adverse impact on millions of people overall. So for that reason, so my point here is like the annotation is actually quite critical step, and I believe so annotation step needs to be defined, and it needs to be taken very, very seriously. And so for example, in our case, like the Twitter verification part or the annotation part, so they didn't use, for example, people who are trained for Islamist extremism or who are trained for like the religion of Islam. They didn't even know about the religion of Islam or what the separation between Muslims or peaceful Muslims or extremists, right? So they just annotated the data just because of the they annotated data relying on their trainings for online cyberbullying and online toxicity, and that's all. So they didn't have the proper knowledge of the domain. So I believe whoever is going to annotate the data, they have to go through a rigorous training for the respective domain, whatever it is. It can be finance, or it can be business application, or whatever it is. I believe it should be taken very seriously, and they need to go through an intensive training.
I totally agree, and you know, in my experience, yes, it works best if the annotator is both a data scientist and somebody with the domain. For example, in our case, it's the medical domain. So you know, typically we have like medical doctors who are also data scientists, and who understand what they're doing and who understand the implication. But I think the models kind of reflect the bias that is already there in the world, right? They are trained with text data, and whatever bias you have in Wikipedia or in the in the original training data, like even before the annotated data, even in the unsupervised. There's a lot of research about fairness and bias and all of those problems.
That's right.
Are all reflected in the AI model. There is research about minimizing that, but it is what it is. Like the world is not is not perfect, and they just reflect the imperfections that we have in the.
Sure, I completely agree. It is. We are not living in a perfect world, and our society is biased, and this bias is being reflected on the data that we are collecting from the society. On the other hand, we have been working on a particular AI technique, for example, that is not relying on solely data sets. So because data sets are being created by the people, and humans are biased, and we are collecting them from society, and society is biased, right? And how to minimize them, or how to mitigate bias or any unfairness in your model. So then an external knowledge can actually come into play. For example, you can structure the external knowledge in a structured form, for example, a knowledge graph or an ontology. Then you can actually incorporate that particular knowledge, because it is mission readable, right? So as long as it's mission readable, so you can take that knowledge and incorporate your machine learning or NLP models. So that can actually, and that's what we see actually in our research as well, and that's what we published in the past. So it is actually, it's going to mitigate the unfairness in your model, even though it's not possible actually to remove them completely, but it's going to mitigate actually the bias in your model. So for that reason, relying on the data set completely is actually kind of as far as we observed, it is not actually a great idea. Then an external knowledge in a structured format is going to be more crucial, I believe, in mitigating that unfairness. And also, the world is changing and evolving all the time, and the data set that you have is going to be it was like collected like in the past, and it's not going to be represented after some time. Then you have to actually retrain your model or readjust your model. Okay, I talked too much, so maybe you can continue.
We'll have to invite you as a speaker next time. I noted your information, so you are in my list.
I mean, of course, I'm happy to chat. Not a talk maybe, but I'm happy to chat, of course.
So thanks for sharing. And those are like fair, and those are actually problems that we're facing in our day-to-day work. So you mentioned the concept drift, and also the data drift and distribution drift. Like those are things that you face when your model like goes there in the jungle, right? That faces reality. And there's research and ongoing research. There are amazing like papers and works that are being published every day. And I mentioned in the beginning of my speech that this is one of the fastest evolving fields that I've seen, and I've seen quite a few of them so far. Like just last week there was a conference. I think almost 1,000 papers were published there. And as like you mentioned, graph networks. Those are I think I totally agree. There's a lot of potential there, and I think that we've been thinking a lot about incorporating this domain knowledge into the models, and BERT doesn't allow you to do that. It's kind of a black box. So graphs have that potential, and I totally agree. Like there's a lot of they can be the next revolution.
Sure, I agree completely.
So I can continue with the very short demo that I had, and we can conclude from there. Let me just try to share my screen again. This is here. Okay, so stop sharing. Okay, so this is Hugging Face, and this is the website with information about the transformers. And here you have pre-trained models that you can use to do different things. And also there are example or sample usages that can be used. For example, if you want to use Alberta, and you can just use write a few lines of code, and you can leverage these models. Or if you want to do BERT, or even like if you want to explore other models and what can be done with them. Typically, I would kind of divide this into two kind of models. One is the autoregressive models, such as GPT, which are typically used for generation, or mask language modeling, MLM based models such as BERT or Alberta. Like they are similar to each other, and there the training is different, and also their usage is typically for classification or maybe name ethnic recognition, NER. So just a simple application that I did, like using those codes there. So let's say you want to do some classification, right? And I put some some average text here. So this is how you just load the models. And I'm doing all of this locally. Thankfully, my laptop has good parameters, so it can load the model in the local memory, and I can generate sentiments based on this model, right? For example, when I do get sentiment from a BERT-based model of this is amazing, and this is from 0 to 10, it gives me quite a low score. And the reason is because this is the pre-trained model. I have not fine-tuned it to do classification yet, right? So it knows how to understand the language, but it doesn't know how to do classification. It is not improved, or it is not optimized to do classification. So I have not done fine-tuning myself here, but I have loaded another model, which is again BERT, but it has been trained on doing classification, and it is trained on doing sentiments classification, basically. So here, when I do get sentiment using this BERT SST2 model of this is amazing, it gives me the maximum score of 10, right? Which is what is expected to do. So you can try with like longer sentences and things like that, and this will be quite consistent. So say this is a very simple and straightforward way of getting sentiments out of like reviews. Like if you have a research idea to do something like that, you have reviews and you want to get the sentiment score, then this is a very straightforward and easy way to do that. You don't have to be an expert in NLP. Just if you know a little Python, and this is very, very easy to do, actually. Or if you have like long paragraphs, then this is another challenge, because I think BERT has a limitation of 512 tokens. Above that, it's just going to ignore them. So you can divide the document into 512 length paragraphs, and you can kind of get the average score. You can aggregate the score somehow. So this is how you basically can use AI if you had heard a lot about it before, and if you're wondering, or if you're curious about how it can be used. The application is actually very simple, and what I'm using here is Jupyter notebooks for those that have not used them before, and they are very easy to use, and also you can like do plots, and you can visualize everything at the same place. And when I first learned about Jupyter notebooks, I really loved them, because this is a way of writing both the code and getting printing the results and also plotting them at the same place, and you can save this as a PDF, which is really amazing.